Hi everyone, hope you're doing well. This is a video for Do Now number 7 for Regents review. Okay, please make sure that you're posting all these pages for me on Google Classroom so you get credit for the classwork. And we have a couple different things that we're going to work on today. So let's get started. Okay, so for the first thing this is for the following tables. Decide if they are linear, quadratic, cubic, or neither, and then graph on the calculator to check. So I'll show you that. All right, so the last time we did this was with our average rate of change. So you have seen this already, and there is a shortcut that I taught you. Okay, anything linear, remember linear is x to the first power. So anytime you get a first common difference, it's going to be linear basically. Quadratic is x squared, so this would be the second common difference. Cubic is to the third power, so this would be the third common difference. And then I taught you for neither, it's usually one of two things. It's either exponential or absolute value. All right, actually before we start, I'm going to write something over here. So the shortcut only works if the x values, that's your domain, are +1. So they have to keep going by 1 to do the shortcut. If not, you have to do the regular slope, change in y over change in x. Remember this, y2 minus y1 over x2 minus x1, and show the rates of change are constant. And show the rates of change are constant. But for today, we're going to work with ones where we do have this common difference, or, you know, the x value is going up by 1, so we could do a little bit of a shortcut. Okay, so from 1 to 3, it's +2. 3 to 5 is +2, +2, +2, and +2. All right, so it looks like they're all the same on the first try. So first is linear, so this is going to be linear. So linear, because the rate of change is constant on the first try. You could say try, you could say trial. I think I also had said in class, first common difference, you can also say. All right, next one. So these all go up by +1, so that allows us to do this trick. So -7 to 0 is +7, 0 to 1 is +1. Then we have a +1, a +7, and a +19. So as you can tell, these are not common on the first try, so it cannot be linear. So let's keep going. 7 to 1 is -6, 1 to 1 is 0. Then it looks like we have a +6 and a +12. So no good on the first try, no good on the second try. Let's see the third try. So -6 to 0 is +6, another 6, and another 6. So we are correct, or common difference is on the third trial. So 1, 2, 3, third would be cubic. So cubic, because the rate of change is constant on the third try. Or again, try, trial, whatever you want to write, or third common difference. And again, I'll show you at the end how to do these on the calculator. All right, moving on to C. Okay, +1, +1, +1. So 8 to 3 is -5, 3 to 0 is -3. Then we have a -1 and a +1, so linear, no good. Let's see what we have. -5 to 3 is +2, -3 to -1 is +2, and we have another +2. All right, so second common difference, 2 is quadratic, and so this is quadratic. So quadratic, because the rate of change is constant on the second try. Okay, again, we can write second common difference. All right, D, and then I'm going to do another one. I'm also going to write your notes for the calculator. Okay, so what do we have? That is -1. Then we have a -1, another -1. Oh, so I guess this is -1. Oh, nope, it is +1. They're so mean. Of course, they're going to make the last one different. So, okay, we know that is not linear. This is +0, +0, and +2, so it's not quadratic. And this is +0, +2, and it's not cubic, so it's nothing at all. So it's nothing at all. We say neither. because the rate of change is never constant, okay? But usually they're pretty easy to pick out which one it is. If you just notice, all these x values that are negative become y values. So negative becomes positive. Therefore, you should really be able to tell that this is absolute value, okay? All right, let's sneak another one onto here. X, Y. So 1, 2, 3, 4, and 5. And your numbers are 10, 20, 40, 80, 160. So now as I'm writing those y values, you should already actually know what this is. But these all go up by +1, which allows me to do like this shortcut thingy up here. Okay, so we've got +10, +20, +40, and +80. So linear is no good. +10, +20, +40. Those are not constant. Quadratic's no good. Then +10, +20, no good. All right, so this is going to be a neither. So neither because the rate of change is never constant. Okay, so if you notice 10, 20, 40, 80, 60, what's happening to those y values? If you notice, they're all doubling. If they're doubling, you should know by now double means exponential. So this is exponential and our ratio is 2. That's because we're looking and we see the y values double. Okay. All right, so let's check these on the calculator. So I'm going to write the steps first and then I'll show you how to do it. So put the numbers into L1 and L2. To do that, remember you press stat and then press number 1, which is edit. And then we want to go to second, y equals, to turn on the stat plot. And I'll show you the other shortcut too for that. And then you want to press zoom and stat. And zoom stat is going to help you to see the dots. So once you see the dots, you can kind of figure out what it is. All right, so let's do, let's do a quadratic. So stat 1. So we're going to quickly put these numbers in. So -3, -2, -1, 0, 1. Then we have 8, 3, 0, -1, and 0. So we're going to go to second y equals. We're going to turn this stat plot on. Okay, I did tell you I was going to show you a little quick shortcut. If you actually just press y equals, see how that now is highlighted? When it's unhighlighted, it's not on, and when it's highlighted, well, it is on. All right, so now that it is on, if we press zoom, so here in the middle, zoom, and then we're going to go to stat, because this was technically in the stats unit, you can see that it looks like it is a quadratic. It is curved, okay? Stat 1, let's do another one really quick. Let's do our, oh, I should have left those x values in, whoops. -3, -2, -1, 0, 1, 3, 2, 1, 0, and 1. And we're gonna go to zoom and we're gonna go to 9. And you'll see that it's more of a straight, so this is more absolute value. Okay, you got that V. And then one more lesson I want to show you. Let's try this one over here. 1, 2, 3, 4, 5, and 10, 20, 40, 80, and 160. And we'll show you how this one is exponential. Zoom stat. And you can kind of see that it is curved, okay? So sometimes if these are multiple choice, it's a little bit easier to do it on the calculator before you're doing all this work. So, all right, so that is the first part of our do now. Okay, so the second page is about exponents. I thought it was important to do some questions on this. I feel like it's been popping up a lot lately on the Regents, and you might be a little confused, so I thought this might help you out. So here we go. Number 1, Miriam and Jessica are growing bacteria in a laboratory. Miriam uses their growth function f of t equals n to the 2t, while Jessica uses the function g of t equals n to the 4t. N represents the initial number of bacteria. That's going to be important for us. And t is the time in hours. If Miriam starts with 16 bacteria, how many bacteria should Jessica start with to achieve the same growth time? Okay, so it talked about the initial number, and that's going to be this one here for starting. So initial equals starting amount, okay? And the rule that we're going to use is something called the power to power rule, okay? And essentially what that is you have the base of x, the exponent of a, so x to the a raised to the b. And what that is a times b. Because you can think of it this way. Think of that a parentheses is multiplying, right? So this times this equals this times this. So kind of use that to help you out with this stuff. All right, so Miriam, her equation was f of t equals n to the 2t. And they told us what she started with, so her n is 16. So f of t equals 16 to the 2t. So watch what I'm going to do now. I'm going to do, instead of 2 times t, I'm going to replace the multiplication sign with a parentheses. I'm going to put this on the inside and have the t on the outside, okay? I'm allowed to do that because of this rule. Then I'm going to do 16 squared. 16 squared is 256. And now I have 256 to the t. So now we're going to work on Jess. And her equation was g of t equals n to the 4t. So g of t equals, all right, so I know this is multiplying, right? So I'm going to do the same thing I did here. I'm going to take the n to the 4th and put it inside the parentheses. So now see how they both have a t on the outside, so I'm getting closer. So now what I need to do is I need to figure out what number to the 4th power is t. So you're kind of just going to, use all those as your guesses. So 32 to the 4th power, that's no good. 16 to the 4th power, well, that's no good. 8 to the 4th power, no good. And then we have our actual answer of 4 to the 4th power, which gets us that same 256. So we have 4 to the 4th power, and we're going to do 4 to the 4th power, and that's going to get us that 256t, and they match. So this is choice D. So basically, can move the exponents. That's what allows us to get this right using that rule. All right, number 2, the growth of a certain organism can be modeled by C of t equals 10 times 1.029 to the 24t, where C of t is the total number of cells after t hours, which function is approximately equal. Okay, so we're also going to use the power to power rule. So the same thing as the first one. Okay. All right, so let's copy what they give us this time. Only working with 1 instead of 2. All right, so I'm going to do basically what I did above. This is multiplying, right? This is technically also multiplying. Multiplication is commutative. So I'm actually going to take this and put it inside with the base. So 1.029 to the 24th with that t on the outside. So again, you can move stuff around. Then I'll put this in the calculator, 1.029 to the 24th, and you get this long decimal. So I'm going to copy that decimal. So C of t equals 10 times 1.985953129, and to the t. And if you notice, that is close enough to that answer right there. So that's number 2, C. Okay, number 3. A computer application generates a sequence of musical notes using the function f of n equals 6 times 16 to the m, where n is the number of the note in the sequence and f of n is the note frequency in hertz, which function will generate the same. All right, so another one for power to power. And that is this. Okay, so let's copy that down. F of n equals 6 times 16 to the n. All right, so I guess this one is kind of working backwards because here we kind of had the exponent and made it into a number. Here we have the number, we want to work backwards and go back to the exponents. So you're never going to really touch this, so those two are gone. You're just going to really work with what is inside the parentheses. And you have to think of some number to an exponent that is 16, okay? So your only numbers that are going to work are 2 and 4, okay? Because you have 2 to the 4th power will get you 16, and then 4 squared will also get you 16, okay? So I'm going to show you the right answer, which is 2 to the 4th power. And then remember, this really means multiplying. So because of, multiplication commutative, I'm allowed to move this one out here. And again, we converted the 16 from the beginning. So what I'm going to do is I'm going to take that 4 and now put it to the outside. So I have 2 with 4 and n on the outside, and that is that answer. Okay. Now, I kind of before told you that you could have technically, I guess, done 4 squared. So I just want to show you. I'm just going to work on the inside. So if someone would have chosen to do 4 squared, right? So 4 squared with the n on the outside, you could actually keep going. Now remember, 4 is really 2 to the second power. So you have 2 to the second power, then you have another power of 2, then you have that power of n on the outside. Well, 2 times 2 is 4. So I have 2 to the 4th power to the n, and then we know we multiply these, right? If they're on like this, we just multiply them for n is 4n, and that's how we got that answer there, 4 times n. So really, essentially, you would have gotten the same exact answer, just ours is a little bit, I guess, quicker though. All right, number 4. Nora inherited a savings account that was started by her grandmother 25 years ago. This scenario is modeled by the function a of t equals 5,000, 1.013, and that says t plus 25. So a little different on this one, where a of t represents the value of the account in dollars t years after the inheritance. What the function below is equivalent. Okay, so this one is going to use a different formula. This one's going to use, or rule. This one's going to use product to power rule, okay? And this is really your basic multiplying. It says you have the same exact base and you multiply them. What you do to get your answer is you add the exponent. So very important, base must be the same. Okay, so again, we're going to start with what we are given. 1.13 t plus 25. Okay, so what we're starting with here is basically this side right here. Okay, we have our base, and then we have our 2 exponents. So if we work backwards, we're going to basically take each exponent and apply or make that the base. Okay, and that's what we're going to do here. So we're going to take the t exponent and give it a base of 1.013. Notice there's a multiplication sign in between. And now we're going to give this exponent the same exact base because that's the only way that this works. And that is this answer right there. So that's how you do that one. All right, 2 more. Number 5. The number of bacteria grown in the lab can be modeled by computations. P of t equals 300 times 2 to the 4t, where t is the number of hours, which expression is equivalent. Okay, so this one's going to be going back to the power to power rule. And that was our x to the a raised to the b equals x to the a times b. Okay, so let's start with what we are given. And now we're going to take exponents and make them into different numbers. Okay, so we have 300. Remember, this is really a multiplication sign. So that allows me to write it like this, because this is really a multiplication sign. Okay, and then what I'm going to do is I'm going to simplify that 2 to the 4th power, which we know from number 3 down here, that is 16 to the t. And then you could just basically take away the parentheses and you have your answer there. So here we were converting the 2 to the 4th power. All right, last one, number 6. The population of a city can be modeled by P of t equals 3,810 times 1.0005 to the 7t, where P of t is the population after t years, which a function is approximately equivalent to P of t. All right, so this is my last one. That is my power to power rule. Okay, so all of them have been this one except that number 4. So the Regents definitely likes this. Okay, so let's start with what we are given. And hopefully me doing this helps you do some of those exponent questions in the future. Okay, so this is really 7 times t. So what we're going to do is we're going to now move the 7 in here. Okay, we can do that because this is multiplication. The parentheses is multiplication. Multiplication is commutative. So put that over there. Then we're going to put this in the calculator. Okay, so we have P of t equals 3810. Okay, so we have 1.0005 to the 7th power. We have that really long decimal I'm going to copy right now. 1.003505.254 to the t, and that looks like that is choice B. All right, so hopefully after these couple of questions, these exponents got a little bit easier for you. Okay, so the last page is for the discriminants. And the discriminant is the name given to the expression that appears under the square root or the radical sign of the quadratic formula. So here's the quadratic formula. This is underneath the radical sign, and b squared minus 4ac is the discriminant. Okay, the discriminant tells you about the nature of the root. So this is just one way that they can actually ask you the question, and they want you to do the discriminant. And the second way is how many roots. Okay, if it says how many roots, they're also asking for you to do the discriminant. All right, so we'll start again. So discriminant tells you about the nature of the roots of a quadratic equation given that a, b, and c are rational numbers. It quickly tells you how the number of real roots, or in other words, number of x-intercepts associated with a quadratic equation. Okay, so when I taught you this, I taught you there were 3 different types: positive, 0, and negative. And when you got it, each one of them meant something different. So if you did the discriminant and got a positive answer, that meant that there were 2 real roots. Okay, so let's go through this one and I'll show you. Okay, so A is 1, B is 6, and C is 5. So what you do to get the actual number is you plug in. So we have 6 squared minus 4 times 1 times 5. 6 squared minus, so we'll do the 6 squared first, which is 36. Minus 4 times 1 times 5, and then we have 36 minus 20 equals 16. So you see the positive answer here, so you know there's 2 real roots. Now there's 2 different types of 2 reals. You can get one that is rational, and then you can get one that's irrational. If the number you get is a perfect square, which 16 is, then it's a rational. If it's not a perfect square, then it's irrational. So here, this would be 2 rational real roots. And again, this is rational, and that's because it's a perfect square, okay? If you were given a graph and you had to figure this out, well, you just kind of look at how many times the parabola intersects the x-axis, and you could see that it intersects it twice, so there are 2 x-intercepts. Okay, so parabola intersects the x-axis twice. All right, so next one. 0, if you ever get 0, then there's 1 real root. Okay, so let's go through this one. So A is 1, B is -2, and C is 1. Now be really careful with this one, okay? You have to make sure that you put that in parentheses. If it's not in parentheses, it's going to be wrong, okay? So -2 squared is 4, and then we have 4 minus 4, which is 0. Okay, so if you get 0, it's 1 real root. Now, because 0 is a perfect square, so rational because it's a perfect square, 1 real rational roots. You can assume that anytime you have a 0 as your answer, it's always going to be 1 rational, okay? So this is always going to be 1 rational. Now, okay, so if you look at the graph, you see that the parabola only goes through the x-axis 1 time, so there's going to be 1 x-intercept or 1 root, okay? So parabola intersects the x-axis 1 time. So if you were just given the graph, you can figure that out by just looking at that it goes through 1 time. Okay, so then the last type was when you got a negative answer. A negative meant 2 complex roots. Remember, we also called complex was the fancy for imaginary. And basically what that means is no real roots. That's what it all means. Okay, so let's go through this one. A is 1, B is -3, and C is 10. So -3, again, be really super careful. You have a base that's a negative, must be in parentheses. -4 times 1 times 10, so that's actually a +9. And +9 minus 40 is -31. So you see we get a negative answer. So it's 2 complex roots, 2 imaginary roots, no real roots, anything like that. Just make sure it says 2 and not 1. And if you've ever given a graph, what you notice that this parabola never intersects the x-axis at all. That's why you could tell there's no x-intercepts, which means no roots. So parabola doesn't intersect the x-axis at all. Okay, so whenever you are given a question that asks you about the nature of the roots or how many roots, it's really just asking you to do the discriminant, which is this formula you have to memorize, and then you just analyze what you get. Positive is going to be 2 real roots, either rational or irrational, depending on if it's a perfect square or not. 0 is going to be 1 real root, always rational because 0 is a perfect square, and negative is going to be 2 complex or 2 imaginary roots. So All right, hopefully this wasn't too bad for you guys. Please make sure you post all of this on Google Classroom so you get credit for this classwork. If you have any questions at all, please reach out to me. All right, take care. Bye.